You tap a blank piece of glass, and your phone instantly knows where you touched. No buttons moving, no pressure switch clicking, just electric fields, tiny charge changes, and fast signal processing that turns a fingertip into a digital coordinate. Myth: your screen senses touch by pressure. Most modern screens do not. They use projected capacitive sensing. That means they watch how your finger, a conductive object, disturbs an electric field already present across a transparent sensor grid. Under the cover glass sits a transparent matrix, often made with indium tin oxide traces. Rows and columns form intersecting electrodes. The controller scans this grid rapidly, measuring baseline capacitance at each intersection like taking an electrical fingerprint of the untouched screen. When your finger approaches, it couples to the field and draws a tiny amount of charge. That changes local capacitance at nearby nodes. The change is small, but measurable. Think of it as dimpling a stretched electrical fabric at one specific location. The touch controller cycles through rows and columns thousands of times per second. It compares new readings to baseline maps, filters noise, and flags meaningful deltas. Once enough neighboring nodes shift together, the system marks a valid touch region. Detection is not just yes or no. Algorithms interpolate between sensor nodes to estimate a smooth XY coordinate. That is why your touch can land between electrodes and still feel precise. Higher sensor density and better filtering improve that perceived accuracy. Multi-touch works because the controller sees multiple disturbance clusters at once. It tracks each cluster frame by frame, assigning IDs so pinch, zoom, rotate, and swipe gestures remain stable. The trick is resolving overlaps when fingers get close. Touch sensing can fail when signal conditions are poor. Thick gloves reduce coupling. Water creates false conductive paths. Charger noise can inject interference. Devices counter this with adaptive thresholds, shielding, frequency hopping, and glove or wet mode tuning. Surprising scale. Each touch involves microscopic capacitance shifts, often femtofarad level changes. Yet the system samples and processes them fast enough to feel instant at 60 to 120 frames per second interaction loops. Tiny physics, huge user experience impact. Capacitive touch is not only in phones. It is in tablets, car dashboards, kiosks, appliances, industrial panels, and trackpads. The same sensing principle adapts to different sizes, gloves, moisture levels, and safety standards depending on the environment. Recap: a transparent electrode grid creates measurable fields. Your finger perturbs local capacitance. The controller scans and filters deltas. Algorithms interpolate coordinates. Gesture logic tracks movement, and the OS maps that touch to an action on screen. If you now see touch as signal processing, not magic glass, subscribe for the next breakdown. We are exploring how refrigerators move heat out of food. This is System Sketch.